This webcast today is being brought to you by Spotlight Cloud from Quest. Spotlight Cloud is the first Azure-hosted database performance monitoring solution that focuses on SQL Server customers. It really gives you all of that information and knowledge that Quest has put together over the years with their Spotlight series, and leverages the Azure platform to give you performance monitoring on both your databases and your Azure components. With that, I'm going to pass things over to Alex. Alex is going to be presenting, as I mentioned earlier, cubes in the cloud, analysis services in Azure. So let me make Alex presenter. All right, there you go, Alex. You are now the presenter.
Great, thank you very much, Jason. Just give me a couple of seconds to get my screen shared. Okay, that should be showing.
Yep, it's coming through.
Excellent. Right, well, very good evening, good morning, good afternoon, depending on where you all are. Thank you very much for joining in the session today on Analysis Services in Azure. My name's Alex Whittles. Big thank you to Jason for setting up this session and for you all for attending. All of my contact details are on the screen. If you do have any questions following the session, please do feel free to email me, tweet me, get in touch. Always happy to answer any questions on cubes or anything else BI in Azure related. Quick intro about me before we start. I'm on the SQL Bits Committee, the Data Relay Committee. If you are in the UK around October and fancy presenting a data relay, a series of 5 conferences in 5 days and 5 cities in 1 week. Session submission is currently open for another week, so head to Data Relay Co UK. I've also got a master's degree in business intelligence. I'm a data platform MVP, and I run Purple Frog, which is a BI consultancy in the UK specializing in Microsoft BI, data modeling, data warehousing, ETL, Azure, Power BI, etc. We also have a software as a service platform, PowerBI Sentinel. If you need anything automating in your PowerBI.com estate, automated backups, documentation, data lineage analysis, then head over to PowerBISentinel.com and take a look. Right, so on to the topic. What are we covering today? SQL Server Analysis Services as a service. What I think is quite probably Microsoft's best ever acronym they've ever come up with. SSAS Genius. It is cubes and hosted up in the cloud. So before we start with actually the specifics of that, let's have a quick look at where cubes have come from and where they are now, and the various flavors that we can use. So initially, back in SQL Server 7, Microsoft released OLAP services, which was the starting point of cubes. And that's when they bought Panorama software, and they gradually started enhancing it from there. Analysis services as we know it really started in SQL 2000 in its multi-dimensional form, which is very, very disk-based. It's a relatively complex tool to get up and running, has a lot of requirements of data quality, a lot of challenges around the optimization, scalability and performance of it. So it really did take quite a bit of tuning to get working. There were 2 modes it could run in. One's MOLAP, one's ROLAP. MOLAP was importing all the data from your data warehouse into its own multi-dimensional data store, or it could query live and basically act as a pass-through engine to just store the semantic layer, the calculations and KPIs, and pass the query on through the underlying database in the ROLAP mode. Then from SQL Server 2012, Microsoft introduced the new tabular model of cube, which is, let's say, an upgrade of the multi-dimensional model in its performance and capability. Initially just in performance, it was an in-memory tool, so instead of being disk-based, had a lot of performance enhancements by being in memory, using what they call the Vertipack tabular engine. Very heavily compressed, normally around 10-to-1 compression of your data when it goes into memory. Essentially an optimized column store engine. And that had 2 modes again, in memory, where it sucked all the data in, compressed it all, kept it in memory, or the other mode is direct query, where it acts as a semantic layer and passes the query on directly to your underlying data store, SQL Server database, etc. Then from 2015, Microsoft first released the public version of Power BI, which actually behind the scenes uses exactly the same in-memory Vertipack engine. It's almost the same code base as Tabular Model Cube. More aimed at the power user rather than a corporate server environment. Between tabular and multidimensional, they are targeted towards a corporate enterprise grade. Install a cube on a server. You've got a development team managing that cube. It's tested, it's gone through a DevOps process, it's been released, etc., and managed. Power BI is a lot more of a everyone for themselves, create your own Power BI documents. But behind the scenes, it's the same in-memory Vertipack engine, just limited in scalability. Power BI does have the benefit also of having the built-in dashboarding facility. If you divide Power BI into two, the dashboard and the data store, you can also point that Power BI dashboard directly at a server-side cube, tabular or multidimensional. If you're going to point Power BI at multidimensional cube, be prepared for some performance issues and some functionality issues. If you're going to use Power BI, I definitely would recommend Tabular. Tabular was always the faster but less capable brother of multidimensional cubes. The announcement that Christian Wade made at SQLBits this year of bringing in functionality such as the calculation groups really does bring Tabular for the first time pretty much on a par with multidimensional cubes in terms of functionality. So pretty much these days, if you're going to create a cube, Tabular is the way forward. Only go to multidimensional if you have a very, very specific scalability or functionality need, but they are pretty rare. Normally Tabular is the way forward. So today we're going to be looking at the tabular model. Primary reason for that is that if you want to deploy a cube into Azure, tabular model is your only option, unless you spin up a virtual machine and host multidimensional on a VM. Tabular cubes can be deployed as a service in Azure without any infrastructure. So you can either create tabular on-prem. When you install SQL Server, you can install a tabular instance and manage it on-prem. Pretty much the same cube with the same code, you can also now deploy directly into Azure. So we'll be focusing on that process of managing it in Azure rather than the on-prem side today. But we'll also be looking at how that compares with Power BI, especially Power BI Premium, and why would you want to use a cube over and above Power BI Premium. So one of the challenges you've got with Tabular Cube is the infrastructure of how data gets moved around and where you do various things. So here we can see a very simplified architecture diagram. So we've got our data sources on-prem down here on the bottom left. We've also got maybe some cloud data sources, Azure SQL DB, SQL DW. All of those can be consumed by a cube that's sitting up here in the cloud service. All of the authoring is done using Visual Studio, same as you would do with any other cube or integration services project, for example. Visual Studio locally on your machine, you create a project and you deploy it up into the cloud. To actually manage your cube, use Management Studio, exactly the same tools as you would do if you were doing it on-prem. Then once you've got the cube in the cloud, you can then consume it by using any on-prem reporting systems or cloud-based, such as Power BI, that can talk natively directly into analysis services. The key bit is this item in the middle. When we're using an on-prem SQL Server database as the source, if we're consuming that in an on-prem cube, there's no problems. They sit next to each other on maybe different servers, but they're on the same LAN. When we have analysis services up in the cloud, when we do a process of that, we have to suck the data out of the on-prem data source and find a way of providing it to analysis services up in Azure without having VPNs, etc. And so the tool that does this is the on-prem data gateway. It is exactly the same data gateway as we have with Power BI. So it used to be different, now it's all one consolidated on-prem gateway. And so this on-prem gateway we install locally on the server, and that gives access to SQL Server databases, local analysis services cubes, SharePoint file stores, etc., and provides access to those that data to various different Azure services, Azure Analysis Services, Logic Apps, Power BI, Power Apps, etc. So once you've got your on-prem gateway configured, it can be used by a multitude of these services. That's probably enough slides for now on the background theory. Let's just jump straight into pulling up Visual Studio and creating a cube from scratch. It's only going to be a simple cube, but talking you through the process of how you create it and what it looks like. This session is not going to be about the ins and outs and details of data modeling in cubes, the DAX code, the things like that. It's more about the differences between on-prem and cloud. But I will go through the process of creating a cube from scratch just to give you some context. So here we've got Visual Studio. I'm going to create a new project. and that project is going to be a BI project, Analysis Services and Analysis Services Tabular. If you already have a tabular cube, you can import it using this option, which will download the structure from the existing cube server and bring it into Visual Studio. But we're going to create a new one from here, and we'll call this Tabular Project 4. That's good enough. So whilst that's creating our project, when we create a tabular cube, we need to have a workspace on where that cube can host its data during the development process. Same as in Power BI, when you start working on data, you have to bring the data in, and it builds that cube in the background whilst you're designing it, so you can instantly see the results of calculations. We do the same thing in cubes. We can either, if we have an existing Analysis Services tabular deployment on a server, we can choose that server here. If we don't, we can choose Integrated Workspace, which will spin up a hidden instance of Analysis Services locally on your development machine within the memory space of Visual Studio. I've got a cube server that I can use, so I'm going to choose this one here. We then have to choose our compatibility level. You can target any version of SQL Server. If you're going to deploy this to Azure, you have to choose Compat Mode 1400. That's the only one that is compatible and can be deployed to Azure Analysis Services. So we'll choose 1400, and that will then create our project. So on the Solution Explorer, we have the projects and we have a single .bim file. And let's jump back to that screen. And that one .bim file is the entirety of your Analysis Services cube. If you unzip a Power BI desktop file, in that zip file, you will find a .bim file. Don't do that, don't change it because it'll corrupt the file, but just out of interest. So we want to see some more details behind that, so we can look at the Tabular Model Explorer pane, and that gives us a bit more of detail of what's happening inside our projects. So the first thing I want to do is to import from a data source. Now what I'm going to do, I've got a local AdventureWorks database on a different machine, which I'm going to use here. And when I choose that server, I'll then be presented with some impersonation details. And assuming that authenticates me, I can then choose from a list of the tables that are in that database. So there's my AdventureWorks. And I can now see my my AdventureWorks tables. So let's go Fact Internet Sales. Let's look at DIM product category and subcategory, and let's bring in DIM date as well. Now what we can do at this stage is, that's loading a preview of the data. We can click Edit on that, and this brings up essentially Power Query. It's a slightly different window than you get in Power BI, but it's the same functionality. So you can see on the right-hand side here, pretty much the same query steps as you see in Power Query. And we can do pretty much the same things that we want to do: transform columns, create new columns, combine them together, etc. On the advanced editor, we now see the M code. So if you have M code in Power Query, you can then use that directly in your Analysis Services as well. So the migration path from Power BI to Analysis Services is very, very seamless. You can also, instead of M query, you can just write a SQL query as your source as well. But we're just going to use the native M from there and import it. So that's now importing that data from the SQL database into the in-memory engine within the development cube. And so we can now see all the data that exists in all of those tables. In the same way we can with Power BI, we can jump to our Fact Internet Sales table, choose a column, and let's create a measure from it. So this creates a a sum of sales amount. Great. It is, to note, the same DAX query as you would write in Power BI. Anything you write in Power BI, you can write in Tabular Model Cube, again, because it's the same engine. The windows that we have here, this top window, or top part of the window, is the data preview window, where you can see the contents of whatever table you've specified. The bottom pane is all of your measures and calculations. So the actual interface is slightly different to Power BI. There is no link between the particular column here and the particular column down the bottom. I like to keep it nicely aligned, so if I'm using sales amount as my primary source for a calculation, I'll align it accordingly, but that could be in any cell. It really doesn't make any difference. So we can now see on the right-hand side, we've got our data source, we've got a list of our measures here, we've got our tables, and within our tables we can see any columns, any hierarchies, etc. So I'm not going to go into any more detail about the structure of building a cube. Hopefully you can see it's relatively straightforward. The data model view, if we look on the bottom right button, we can see pretty much the same data model diagram as we see in Power BI. So if you've ever used Power BI, you'll feel right at home. So let's focus more on actually the deployment and management of this from within Azure. So let's jump into my Azure portal to get things set up. So the first thing we need to do is create an Analysis Services server. So we're going to create a resource. If we filter this to Analysis Services, we can then create a new server. So I'm going to call this Alex SSAS Test 42. And choose your subscription, same as you do with any other Azure resource. Put it in a resource group. I've already got one here for SSAS demo, so I'll use that one. Choose a location, a region, and then a pricing tier. Now the pricing tier, we'll get into in a bit more detail later on as to the differences between the different versions, but as a very high level, D is your developer edition. That is a very, very basic, simple, low power, very cheap, easy one just to play around with for development. It has pretty much the same functionality as the standard SKUs, but obviously a very small scale in terms of size. We then have our B1, B2, which are our basic, and then S0 to S4, which are our standard SKUs. Now, the biggest one here is an S4. You can get an S9, but not in this data center. So if I change this to, I think, West Europe, yeah, that has up to an S9. So do be careful before you create your cube and work out what kind of scalability you want it to have and make sure that the data center you choose can scale to the right level if you do want to scale it up rather than having to move it to a different data center. Normally start out with a D1 and then progress from there. You can set up an administrator and which defaults to yourself, and then we give it a backup storage. So any Azure blob storage that has a container, you can choose a blob storage, choose a container within it, and then whenever you create a backup of a cube, it will go into that blob storage. Very easy to manage. We can either click create, which will deploy there and then, or we can look at automation options, the next button along. And this gives us a couple of JSON files, a template file and a parameters file. Template is the basic standard possible values of the things that need to be provided. Parameters are the exact values that we've specified. So Alex SSAS Test 42, where it is, the SKU, the admin value, etc. And then it gives you the PowerShell script on how to deploy it. So you can copy these files, run that PowerShell, and it will deploy the cube for you. Here's the link to those two template files that are created for us. So if you want to automate the deployment, this is how you do that. It also gives you the .NET code, the Ruby code, etc. So it tries to help you deploy these things in an automated way if you want to. We're not going to bother with that because I have one I created earlier. So let's go to my SSAS demo basic cube, and it tells us the summary about the resource group it's in, etc., the subscription name. Critically, this element here, the server name, is a very, very important string. That's what we're going to use to deploy it, to connect to it, and to manage it. So we can copy that to the clipboard, and we will be using that later on. That's the pricing tier. And down here, we see all of the models that have currently been deployed to this cube, and there are none. So this cube is not a single cube. You can view this layer here as essentially an analysis services server into which you can deploy multiple different cubes. The total capacity of it is defined by the pricing tier, combining all of your different models together. So you can deploy multiple models into the same analysis services. And I would recommend you do that to minimize cost and simplify management. So the first thing we want to do then is to deploy our new cube into this server. So I'm going to copy that server name and go back to my Visual Studio. And if we go back to the Solution Explorer down here, we can then right-click on the project, click Properties, and we can see the deployment server that we want to deploy it to. So that's currently set to my local server. I'm going to override that with that connection string server name that we copied from the Azure portal. Specify the edition of cubes that we're going to target, in this case the developer edition, and give the database a name. Tabular project 4 will suffice for now. Click on that, and then right-click and deploy. And that will deploy our cube up to Analysis Services up in Azure, after it asks me to authenticate into Azure, obviously. Now, this is going to fail. It'll succeed on the deployment, deploying the metadata, the structure, and deploying the cube itself up into Analysis Services, but it's going to fail on the processing. As soon as it deploys, it tries to refresh the data and pull that data into the cube. Now, if we look at the error details here, it's actually going to give us quite a helpful error message. The on-prem gateway is required to access the data source. That's because this cube is accessing a local data source on a laptop sat next to me, but I'm deploying it up into Azure. And Azure at the moment can't see that server. So we need to configure the gateway. So if we jump back to the Azure portal and refresh this, we'll now see that cube we've just deployed. There we go. There we go. Tabular project 4, it's there and available. So if I grab that server name again, we're now going to connect to that same cube in Management Studio. I'm just going to disconnect from there. So if we connect to Analysis Services in Management Studio, paste in that same connection string, and we'll log in with my Azure, my Active Directory username. And then here up in the server, we can see this new database that we processed, that we deployed rather. I'm going to process it here again just to show you the process here. And this again is going to fail because we haven't got that gateway, but it just shows you how to go about connecting in Management Studio. And it's going to give the same error. So what we need to do now is configure a gateway that connects this cube down to our local data source. So I've already installed the on-prem data gateway, which is a nice simple download from the Microsoft website. When you install it, you've only got basically two things you can choose. You can put in your Active Directory username to log in, and you can choose a data center you want to connect it to. I've already done that, but what I haven't done is connected it to anything up in Azure to say there's a link between my Azure account and that on-prem gateway. So I'm going to create a new resource. Now, for some reason, you can't search this for gateway because that doesn't bring up the gateway we need. We have to search for on-prem. So we search for on-prem, create a new gateway. I'm going to give it a name. And choose a subscription, choose a resource group it's going to go into, and choose a location. So this is the data center. Now, because I've already deployed the gateway to my local server, this drop-down list gives me a list of all of the actual gateways that I've installed on my various servers that haven't already been connected to an Azure endpoint. So I've got two here on two different servers. This is the one that I want to connect. So this will then create the endpoint up in Azure that we can use. There we go. That's all been created. So now what we can do is go back into our Analysis Services server in the Azure portal. And down here we have the on-prem data gateway configuration for this particular Analysis Services server. And we can then say, right, these are all the gateways that are available. Now the Analysis Services is in UK South. I know that I deployed my gateway to North Europe. So straight away it gives me an error or a warning to saying there's a performance issue here because my gateway and my Analysis Services are in different regions. But I've got these two gateways already configured. I can choose one of them and that will work. I can connect it. So not going to give me the best performance, but for demo purposes, it's fine. But do try and make sure that when you do deploy this in production, everything's in the same data center, just for performance reasons. So now I've configured that gateway. There's nothing else to do. All I have to do is go back to Management Studio, try and process my cube again, and miraculously, it should just work. Now, because that cube is deployed into that Analysis Services server, there's only one gateway allocated to the server, so it tries to connect to that server name through that gateway. As long as that SQL Server is able to be connected from the gateway machine, then it will just work. So now we've got that, we can now see all of our data in there, and we'll be able to browse that and explore the data. If we go back into our portal and look at the Analysis Services server, we can see our model. If we want to, we can use this as a shortcut to test that model connectivity. We can either open in PowerBI Desktop, which creates a new PowerBI Desktop file hooked into that cube. So that's in live connection mode, where it won't import the data into Power BI. It'll use Power BI as a reporting front end to the cube on the back end. I'm going to open it in Excel, excuse me, just to prove the concept. Obviously, the cube's hosted in Azure, so you need to authenticate using your Azure account to connect. And now we have essentially a pivot table built on top of that cube, so we can pull in and build any query we want based on the data available in that cube. So the actual process of creating a cube for Azure is identical to creating a tabular cube for on-prem. At this stage, there is no difference. I could deploy exactly that same model to an on-prem cube server at the same time. It's the same code, same structure, same data model, same DAX, same source, same Power Query source essentially. Everything at this stage is the same. So let's have a quick look at security of how do we manage access to this cube. So straight away we have the Analysis Services admins down here in the management portal. And we can configure here any number of Azure AD accounts that have admin access to this cube. Now that means to this server. That means we can deploy new cubes to that server. We can delete cubes. We have admin access over the contents of what's been deployed into that model. We also have the access control layer up at the top here, which doesn't control access to the cubes and the data in the cubes, but controls access to this portal window. So if we look at the role assignments here, any users in any of these groups can access this Azure portal. Therefore, you can manage things like the configuration of the server, the pricing tier, whether it's an S0 or an S1, for example, scale it up and down, change the properties, the security and the configuration of the Azure portal. Critically, not the data inside the cube. To access the data inside the cube, you need one of two things, either to be an Analysis Services admin, using this option we saw earlier, or we can configure role security in the cube itself. So if I jump back into Management Studio, we can now see, as well as the connections and the tables, we also have roles down here, of which at the moment we have none. So I can create a new role on this in this cube, and this defines access to a particular role. So let's call this test role. and they can read the cube. Are they an administrator of this particular model that's been deployed or not? Can they process this model or just read the data inside it? Let's just go with read for now. We can set membership, so we can add individual people into this. So let's add Nick. No, Nick hasn't got any access to this. Let's go Jeet. That not? That should search and give me the values, but it's not, so I'll do that for now. So note, this is the Active Directory username, so the email address, not the actual purplefrog/Alex local domain, because this is an Azure-based system. So we can add people into there. We can also add AD groups into there. There are some considerations with AD groups, which I'll get to a little bit later on. So as soon as I do that, then we now have a role here. So if Jeet then tries to connect to the cube, it'll look at that role, match him against that role, and then give him access. You can also make these roles a lot more specific in what they can access with row level security. So as well as membership, we can also specify row filters. So I could specify here, for example, a DAX filter on this that says something like, let's go, English product category name equals bikes. So that essentially applies a mandatory filter to anyone that's in this particular role that enforces that filter to be executed on every row of that relevant table. So before any filter context or query context is applied, it will filter this dim product category to only those rows where that DAX expression equates to true. It has to be a Boolean result of that. That then gets applied as a filter to any table that's linked to that, any other tables linked to that table. And then on top of that, you apply the actual filter queries, the query filters that the user has applied. So we could create 5 different roles here, one for bikes, one for accessories, one for clothing, etc., and then allocate people into the relevant roles for that. There is, however, some more interesting things we can do with security. So let's jump to this. We've seen that. When we create roles, we can either create them live in Management Studio on the deployed cube, or we can create them in Visual Studio so they're part of our project. I tend to prefer creating the roles and the definition and the security aspects of the role in Visual Studio, so they're source controlled, the same roles as deployed to dev, UAT, production, etc. However, the membership of those roles I tend to leave to manage within Management Studio. That means you can have the same role definitions in your dev, UAT, and prod environments, but you can have different members within those different environments. But it's up to you how you want to manage that. So you can configure those in Management Studio, or whether you do it in Visual Studio, it's pretty much the same interface. If you want to create groups, and it is much easier to allocate group permissions rather than individual users, so then you haven't got to keep changing your role structure and contents every 5 minutes, you need to be very careful how you create your groups. If you create your groups in the Office 365 Active Directory portal, then when you create a group, it has to be a mail-enabled security group. If it's not, you will not be able to use it for security in your cube. If you create your group using the on-prem Active Directory users and computers, then the critical thing here is to give it an email address. By default, when you create a group, this email address field is blank, and that will cause you all sorts of grief in trying to manage your permissions. So make sure you do give it an email address. If you don't give it an email address, you'll end up with security looking something like this, with GUIDs flying at you left, right, and center. And then you have no idea who's got access to what. So as soon as you give it an email address, it turns into an actual proper one that you can understand and use. So once you've configured your groups, you then want to specify the row level security on that cube. And as we saw earlier, we can apply a hard-coded DAX expression to a single table or multiple tables that evaluates true or false. We could even just give it a fixed figure of a fixed DAX or false if you want to remove any access to that table. More often than not, you actually want to put in dynamic security, where you've got a configuration table that maps a particular user against what they can see, and you want the row level security to be dynamic. So we do that using a dim table for the user. So here we've got the user ID, their name and email address, and then a fact bridge table that maps a particular user ID to, in this case, a sales territory. And then that cross-filters to our dim sales territory. Now, it's critical that this relationship here is a bidirectional relationship, because normally the filters go from a dimension to a fact table. Here we want it to go both ways. So when we apply security on this dim user table, it then filters our bridge table, finds all the relevant sales territories that are relevant for that user, and that then filters our dim sales territory, which then applies a filter off to our fact tables. So it's very easy to set up. And all we then need to do is in that row filter within our role, we need to specify a DAX expression for the dim user row filter of the user email address equals user principal name as a function. And that user principal name gives you the Active Directory email address that is being used by that user being logged in. This is one of the only differences between developing a cube for Azure and developing a cube on-prem. If it's on-prem, you don't want to use user principal name, you want to use username, because username gives you your domain /user, purplefrog/Alex, for example, whereas user principal name gives you alex@purplefrogsystems.com. So that management of that security is the only difference really between on-prem and Azure from a design perspective. Okay, so let's now jump back into the Azure portal and look at some other different ways of managing our cube once we've got it deployed. So one of the first things we want to do is this pricing tier that we first created. We've created our cube on a D1. Now it's going into production. We want to then scale it up to give us some better performance. The D1 is limited to its 20 QPUs. Now a QPU, query processing unit, is roughly equivalent to 20 QPUs per virtual core of your CPU. So a 20 QPU is largely equivalent to a single CPU core, 200 QPUs, 10 cores, etc. So you can use that as a rough guidance on the actual processing capability of your level. But also you've got the maximum size here. So you can have up to a 3 gig cube in your D1 instance. If we go to an S4, we've got 400 QPUs, 20 cores, and up to 100 gig cube. If you go to an S9, it's, I think, 32 cores and 400 gig as your maximum size cube, or combined all of your cubes together. So we can then, we've already deployed this server, but we can upgrade these at any time to any one of these different levels. Do be careful though, that you can upgrade from a developer to a basic, but not back again. Once you move up to a B1 or B2, you can never go back to a dev D1. Within basic, you can upgrade to a B2, downgrade to B1 as much as you want. And then the same with standard. You can upgrade to a standard, but never back to a basic. It's a one-way upgrade. But once you're within standard, you can change from an S0 to an S9 and back again as much as you want. And it is quite important to do that to manage cost. Obviously, the cost increases as you go up in different performance. And so do you want it to be at maximum performance at 3 in the morning? Probably not. So you can automate and manage the different scale to scale up during the week, down at weekends, increase the scale at month end, downgrade it after that. Obviously, that helps with the cost, and that's okay if you just want to limit your performance, your QPUs. You can't, however, do that if your cube is 90 gig, because it won't fit in an S2. You have to have an S4. So do watch out for the actual size of your cube as to what level you need. So there's one aspect which is scaling up, which is changing the pricing tier of your cube. But you also, if you just want to keep the same performance, but you want to add more users, you may want to scale out and have a load balanced cluster of your analysis services servers. Now, anyone that's ever tried to do this with on-prem SQL Server knows the pain of creating a load balanced cluster of analysis services. It is not the easiest of processes. However, with one of the key benefits of Azure Analysis Services is this replicas button. Now you can only create replica if you're on the standard pricing tier. I'm not, so I can't actually move the sliders, but you get the point. So with this slider here, you can move it anywhere from 0 to 7, which creates you up to 7 read-only replica servers of that same cube. And once you move that slider and click Save, it's just done for you. That is it. It will create you a fully load-balanced scalable cluster to increase the number of users that can access that cube at one time. So you may well want to increase that at heavy periods at month end, and then scale it back again straight afterwards. Now do watch out that if you are paying for an S9 instance of your server and you add 7 replicas, that's 8 servers in total, you will pay 8 times the amount. You pay again per replica that you bring in. But normally replica is only short term to get you through busy periods, scale it right back down again, and you're only paying for the hours or the minutes that you actually use that cube. What you can also do is this option here is separating the processing server from the querying pool. So if you've got, let's say, 2 replicas, that gives you 3 servers in total, you may want one of them to be entirely in charge of processing, and the other 2 just for querying, which means you can do intraday processing all throughout the day, knowing that that processing will never impact on your query performance. It'll happen on one server dedicated, and as soon as that processing is finished, it'll then replicate to the other clones without impacting the query performance. Again, there's a cost impact on that because you need one server just for processing, but if you need that performance, it's a very, very good good option. And one of the most important benefits of Azure is giving you that ability to scale without having to put an immense amount of work into the infrastructure of doing that. So the next question for that is, well, how do you actually automate that? Because I don't want to manually scale it up and down and in and out every Monday morning. And this is where we get down to automation. So actually, before we do that, I'll quickly show you backups. One thing I showed you earlier when we first set up the server was the backup configuration pointing to a particular blob storage. If I go into my management studio and then back up my cube, I can then give it a name, tabular project 4, click OK, and this will just back up directly to my blob storage. So if I go into my blob storage account, which is that one here, I can go onto my Storage Explorer preview. Look at my blob containers, and I can see the tabular project 4 backup there, which is just an ABF file that you can then download and do whatever you want with. If we then want to restore from our backup, it's as simple as restore, browse, and it gives us a list of all of the files on that blob storage. So it's an incredibly easy management of managing backups. But again, that comes down to automation. How do you automate these backups once you're in there? So for that, we need an automation environment. So I'm going to create a new resource here, and we choose a new Azure automation. I'm not going to create that because I've already got one in place, but there's not really much in the way of configuration options here. I'm going to jump straight into what I've already got and give you a quick run through of what it looks like. So this is my my current automation account. Excuse me. So the important things first are, this is essentially a wrapper or an automation library for PowerShell. You can write any PowerShell and schedule it to run on any basis you want. So the first thing we need to do is import the PowerShell libraries that we actually want. So this is where the modules come in. We go to Modules Gallery down the bottom. And for analysis services, there's 2 that we want. There's the profile, which means we can log into our cube. And then we need the analysis services, this one here. So we import both of those just by clicking the import button. And once we've got those, this then adds a load of functionality to resume, suspend, get details, delete, configure it, test stuff, etc., etc., even creating new ones. So this gives us all the libraries we need to be able to interact with our analysis services. So the next thing we want to do is we don't want to have to create dozens and dozens of scripts, putting in all the details of our different SKUs and server names and everything else every single time. So we want to configure these as variables. So under shared resources, we set up our variables. And these are all of the variables that we want to make reusable through our different scripts. And these are just free text strings. So I've created here a normal SKU and a processing SKU. So I may want to upgrade from one to the other during a processing job. Once we've got those variables, we can start creating our PowerShell scripts. So let's go now to our runbooks. And a runbook is just a set of PowerShell that we can interact with our environment. So here, let's look at the scale up runbook. There's a load of these runbooks available to download and to look at, so you haven't got to write them all by hand. And this one, first of all, gets all the variables that we defined earlier, and then runs through putting some output logging and logs into our account. And it does things like let's make sure that the server state, if it's currently paused, then resume it before we change the configuration. And then if the SKU is not the SKU we want it to be, use the set as our Analysis Services server with a new SKU we want to give it. So it's a relatively straightforward process of using those variables to change the configuration of our cube. Once we've got that, we then want to create a schedule. So we've got a schedule button there that we can then schedule this particular runbook and give it a schedule to run at, here I've got some predefined schedules, end of working day, start of working day, first of the month, last of the month, etc. Once you've got those, then it'll just run in the background quite happily. So I've got one here in our dev environment that just stops all of our cubes at 11 at night, just because I've far too often left cubes running after a demo for months on end and then come out with a rather large bill of an S9 read-only replica cube, which has cost a small fortune. So you can see here it runs every night at 11 o'clock and just stops all of my cubes to make sure that we're not wasting any money. Now you can use the same automation for anything you can do in PowerShell. So that's scale up, scale down, reconfigure it, back it up, etc. Deployment, whatever you want to do with this. You can also use runbooks and the same kind of thing for managing partitions and processing if you want to, depending on how you want to do that. Okay, so the next thing we'll briefly look at, Jason, how are we doing on time?
We're doing pretty good. We got a few questions, but if we don't have time for the questions, we can always I can send them over to you and you can repop it back to them.
Okay, well, give me another couple of minutes to run through some finishing slides and we'll get to as many questions as we can. So, right,
Sounds
okay,
great.
thank you. So one of the things that we need to look at is partition management. Now, this is where it can get a little bit complicated in analysis services. You do need to have the standard tier, which is equivalent to enterprise on-prem. We'll get to that in a second. Do beware with partitioning. It does not give you any query performance benefits. It's only a benefit for processing benefits. You don't want to process an entire cube of 10 years worth of history, so you want to partition each table into being able to be a smaller chunk. In multi-dimensional cubes, it gave you a query performance benefits. In tabular, it doesn't, either on-prem or in Azure. And you do have to manage those partitions. So, for example, here, this is in the Visual Studio. Within our tables, every table, we've got a list of partitions, and you can just create a new partition, give it a name, and give it a query. And that query has to be explicitly specifying which date range or what other partitioning criteria you're using to make sure that data does not go into any other partition. You can automate the creation of these either through runbooks, through C#. There's a great blog by Christian Wade on how to use the tabular object model, the TOM, to manage partition management. It's a whole session in its own right, so I won't go into that now, but do have a read of that blog if you want to know more details. You've also got some PowerShell for creating and processing partitions in there as well. You can also configure partitions manually in Management Studio. If you're doing monthly or yearly partitions, that may be okay, not so much for daily or weekly partitions. So to search for that, just search for AS partition processing and you'll find Christian's blog there. If you want more detail on the automation runbooks, then your client's got a great blog on how to use the runbooks to automate the management of there. So just search for SSAS scheduled auto-scaling and you should find that blog. So very quickly, what are the pricing tiers of analysis services in Azure? So we've got the 3 different levels, developer, basic, and standard. Critically, these are equivalent to on-prem SQL Server, developer, standard, and enterprise. So standard means completely different thing on-prem and in Azure. Standard in Azure is enterprise on-prem. So the pricing ranges from $100 for developer up to $15,000 for an S9 in standard stroke enterprise. So the key difference is the number of cores you get and the maximum memory of that server, going from 3 gig up to 20 gig for basic and 400 gig for standard stroke enterprise. But then the functionality, if you want to have partitioning, direct query, or this scale out option, you have to be using standard. So when you compare that 15,000 price tag per month, what are the other options for managing this? Well, Power BI Premium, which starts out at $5,000 and goes up to $60,000 for a 400 gig SKU. So for 400 gig cube, you either pay $15,000 in analysis services or $60,000 in Power BI Premium. Up to you which way you go. I know which one I prefer. Do be aware that when you change from dev to basic to standard, you can only upgrade, you cannot downgrade. So do be aware of that. So a critical question then is, why am I choosing analysis services? Should I choose analysis services or Power BI Premium? So a very, very high level chart here to give you a starting point. They all support row-level security. For me, an enterprise grade solution is all about sharing data models. I want to have one standard, well-made, optimized data model that's been managed and well-designed and use that for the vast majority of my reporting. That's entirely what analysis services is designed to do, or maybe 2 or 3 models. Power BI encourages lots and lots and lots of models. Yes, you can reuse them, but it doesn't encourage consolidation. And so yes, you can share data models, but it is a little bit dirty in my opinion. Can you connect other tools like Tableau and etc. to cubes? Yes, you can with analysis services. You can now with Power BI Premium since they enabled the XMLA endpoint a couple of weeks ago, but you cannot in Power BI. There's clearly a cost difference. Power BI is very cheap. Premium and analysis services are the more expensive options. With manageability, what can you do in Management Studio essentially? Everything you want to with analysis services. With Power BI Premium is all read-only, so you can view stuff, you can't change it. I'm sure that will change in the future, but at the moment it is it's a low configurable option. Where Power BI Premium really comes in is partitioning. You don't in analysis services, you have to worry about code or PowerShell to add partitions and to manage them. In Power BI Premium, the incremental refresh just takes away all the pain for you. It's very, very easy. Then when you look at scalability, obviously a limit to 1 gig in your Power BI Pro data set, 3 gig in Power BI Premium, unless you've got the top tier of Power BI Pro, Power BI Premium, which is it the P5, I think, where you can have 10 gig, but that's your $60,000 a month option. Whereas analysis services is pretty much unlimited. And so what's the purpose? Well, Power BI is for a single power user or a small team to manage their estate. Analysis services is very much the enterprise grade shared model managed cube. And Power BI Premium sits somewhere in the middle of giving you a little bit of both. Over time, Power BI Premium and analysis services are gradually combining together. They will become a lot closer in terms of functionality over time. So the decision you make now may lead you to analysis services. In 2-3 years' time, it may be Power BI Premium. But because they're the same back-end architecture, code, DAX, security, everything's the same, you're not making a final choice. You can easily chop and change between them over time. So I hope that's given you some so enough of an idea about what cubes in the cloud look like, how they work, and what the options are. We do have a few minutes left for some questions. So Jason, can I throw it over to you to throw some relevant ones out?
Yeah. So let me start. Let's jump up to the top here. let's see here. Can you have multiple endpoints for a gateway?
Can you have multiple endpoints for a gateway? No, you can't. I believe, I've never actually tried it, but I don't think you can, because once you allocate a gateway to an endpoint in Azure, it no longer appears to be able to be selectable in the list. So I'm pretty sure I'm confident in saying no, you can't. It's only one. But you can have multiple gateways.
Okay. And what is the latest? What's the latest with NUMA in SSAS Azure?
NUMA. In Azure, you don't really need to worry about it because it manages that entirely yourself, and you have no control over it. You can't choose whether you're multi-CPU, multi-NUMA or not. My expectation is that when Microsoft allocates your analysis services server to a 32-core server, it is a server that is capable of managing that. Now, they have made big improvements in the NUMA awareness of tabular. It's still not as good as multidimensional in handling multi-NUMA multi-NUMA CPUs, but yeah, it's something you haven't got any control over because you can't choose what kind of underlying infrastructure you put it on. It is just there. And Microsoft are continuing to make improvements to the NUMA handling. But fundamentally, if you've got a 400 gig cube on a 400 gig server, and you've got multi-NUMA nodes, you have to spread it across them, and you can't get away from that. But because it's all handled as software as a service, it's something you can't worry about. You don't have to worry about, so ignore it for now and hope for the best.
All right. And I think we got time for probably a couple more. Have you seen a better compression ratio in AS Azure compared to SSAS on-prem?
No, it is the same engine. It is literally the same vertipack. I think it shares something like 98% of the same code base between Analysis Services Azure, Analysis Services on-prem, and Power BI. It is the same vertipack compression engine. So yeah, you won't see any difference in the compression of the data. Where you will see some difference is how you manage processing. Because each partition is processed independently, the more you partition the data, you can limit the compressions in some ways because of that. But that's the same on-prem as Azure, so you don't get any benefit one way or the other.
Okay, and then I know you covered this, but somebody missed the multidimensional versus tabular cubes. Which is the kind that you can deploy to Azure?
It's only tabular. Microsoft have been promising us for as long as I can remember having the ability to deploy multidimensional to Azure. It's still not come, and I'm not holding my breath. Part of the reason is that the whole Azure infrastructure is designed around detaching storage from compute, and which suits tabular model cubes very, very well because compute and memory stay together and storage is completely separate. Tabular, whether it's on-prem or in Azure, has zero performance impact for your storage. You can put it on the slowest storage possible. It doesn't matter. It's all in memory. Whereas multidimensional, the only way to get multidimensional to perform well is by managing the performance of the storage very, very closely, whether that's through partitioning, SSDs, minimizing the latency between storage and the round trip time. It's very, very storage dependent, whereas tabular doesn't care. And so it's much easier from an infrastructure perspective for Microsoft to put tabular in the cube, in the cloud, whereas multidimensional does give them some problems. I believe they are still working on it, but whether it will ever come to fruition, I don't know.
All right, sounds great. All right, we are at the end of the hour, so I'll forward the rest of the questions over to Alex so you can reach out when you have the opportunity to. And then for those that didn't, Alex has all of his contact information up on the screen, so feel free to reach out to him if I don't get them to the questions quick enough. With that, thank you everyone for attending. Thank you, Alex, for presenting today. I look forward to having. Yeah, thank you. I look forward to having you again sometime in the future. And everyone in the audience, please come back on Thursday because we got another presentation. Thanks and goodbye.